Let's look at this rational equation. It is clearly a little bit more complicated than some of the other ones that we were looking at. So again, our steps are the same though. First, we want to find the LCD. That's going to be a little bit trickier with this. Our denominators, let's just list those out. We have x plus 1, x plus 2, and x squared plus 3x plus 2. Okay, before you go and figuring out the LCD, I want you to factor any denominator that you can. So we've got x plus 1, x plus 2, x squared plus 3x plus 2. That x squared plus 3x plus 2 can be factored. The other two they can't. They're good to go. So looking at x squared plus 3x plus 2, let's factor by grouping. We've got x squared blank blank plus 2. A is 1 times 2. That's going to be 2. And we want to multiply to 2 and add to 3. That's just going to be 2 and 1. So this would be 2x, 1x. And you can put the 1 there if you need to. Group. That's going to be x that comes out. Divide by x. And we get x plus 2. And then here I just have 1, which is x plus 2. And that's going to give me x plus 1 and x plus 2. Okay, perfect. So our two factors for this one are x plus 1 and x plus 2. And then bringing down our other two denominators gives us our list of denominators. Now, our LCD is essentially wanting one of each, but not any duplicates. Okay, what do I mean by that? Do you remember going back and thinking about the video that I did with dividing, or when we were trying to figure the LCD out with numbers? And with numbers, I said multiply everything together and divide by the GCF, or what is in common. It's basically the same thing here, okay? So here's what you're thinking about. Looking at your first denominator, basically you need everything. You just don't need you need one of each, okay? But you don't need repeats. So here I have x plus 1. We're going to include that as our LCD. Here I have x plus 2. We're going to include that as our LCD. And our LCD is going to be things multiplied together. So if you got more than one of these, you're multiplying. All right, but looking at our third denominator that we have x plus 1 times x plus 2. We're going to consider each one of these separately. But looking at x plus 1, I already have an x plus 1 in the LCD. So I'm not going to write that again. Kind of the same thing with x plus 2. X plus 2, I already have that in the LCD. So I'm not going to write that again. So our LCD ends up just being x plus 1 times x plus 2. Great. So the first step we want to do is actually come over here and we're going to rewrite this denominator to be that factored form that we found, which was x plus 1 times x plus 2. That's going to help us in our next step. The next step, again, if you remember on our previous problems, we are wanting to write every single term with the same denominator. And that denominator is going to be this x plus 1 times x plus 2. Okay, so let's take this a term at a time. We have x over x plus 1, and we need to multiply by something here so that both of these end up being x plus 1 times x plus 2. So you already have an x plus 1. What do you need to multiply to get x plus 1 times x plus 2? What are you missing? Well, you're missing the x plus 2. But if you multiply the bottom, you got to multiply the top by the same thing. Okay, so that's the first step. Let's bring down our next term. Minus 1 over x plus 2. What am I missing here from the denominator? I have an x plus 2. I'm missing the x plus 1. So I'm multiplying that by x plus 1 and the numerator by the same thing. Equals, let's write this whole thing out. Let me kind of do this over here. This is going to be 4x plus 3 over x plus 1 times x plus 2. Well, this already has an x plus 1 and an x plus 2. And order doesn't really matter here as long as it has both parts, and it does. So I don't have to multiply anything here, which is fabulous. Okay, So our next step is, now that we've got all of our denominators the same, and you can do it here, you can do it on the next step. I'm going to do it here so that we don't have to keep writing more steps. We are multiplying everything here by the LCD. So our LCD is x plus 1 times x plus 2. What does that do? That means that this x plus 1 and x plus 2 we're multiplying by is on the top in the numerator. But all of these are in the denominator. So we're going to cancel these two with these two, and these two. Again, order doesn't matter as long as it has the parts. And that allows us to get rid of the fractions. Okay, so next step, this would be x times x plus 2 minus 1 times x plus 1 equals 4x plus 3. Now we're going to simplify this, okay? So go ahead and distribute. X times x is x squared. X times 2 is 2x minus, remember you are distributing a negative 1, not just a 1 here. So this would be negative x, because 1 times x is just x. And negative 1 times 1 is negative 1. Careful there. Equals 4x plus 3. Once you've distributed, again, ask yourself, what type of equation do I have now? And the highest exponent on the variable is 2. So this is an x squared. This is a quadratic. So we want to eventually get this equal to 0 so we can factor and then set those factors equal to 0. We've got some work to do on this one though. We got too many terms. So let's add like terms first and then we'll talk about what to do from there. So we've got x squared, 2x minus x is just x, minus 1 equals 4x plus 3. And we need this equal 0. So the 4x and the 3 on the right-hand side has to go to the left. I've said this in a previous video. I'm going to say it again now. Wherever the x squared is, if it's positive where it is, you keep it where it is. Move everything over to it so you can have it equal 0. Don't make the x squared negative. Okay? So that means we are moving the 4x. I'm going to do both of these in the same step. So I'm subtracting 4x and subtracting the 3. That's going to give us x squared minus 3x minus 4 equals 0 because these cancel. Now we've got a trinomial on the left and we can factor by grouping just like we've done. So this is going to be x squared blank blank minus 4 equals 0. A is 1. 1 times negative 4 is negative 4. We're adding to negative 3. Clearly, it's going to be 1 and 4. But what are our signs going to be? So B is negative. So that means 1 is positive and 4 is negative. Let's put the negative 4 first. Okay, you don't have to put the 1 there if you don't want to. I normally don't, but it could be helpful. Let's group. In the first group, we always have an x come out. So we're going to divide by x. And that's going to be x minus 4. In the second group, I don't have anything in common. So it's really just 1. And I'm dividing by 1. So that's x minus 4 equals 0. Check to make sure your parentheses match. And in this case, they do. That can take us to the next step. So our next step is x plus 1 times x minus 4 equals 0. And then let's bring it up here and solve each of these by setting each one equal to 0. So x plus 1 equals 0. X minus 4 equals 0. Minus 1 for both. That's going to be negative 1. And plus 4 for both. That's going to be 4. Okay. This is not the final answer. No, everybody's like, what? I just did all that work and this isn't the final answer. Yeah, that's true. Remember that I care less about the answer than I do the process and you understanding how to work the problem. I want the understanding and I want to be able to see that understanding through your work. I know what the answers are, okay? I need to see that you understand the process, okay? All right, that said, one part of understanding is that these are fractions to begin with in these problems, in this problem. Fractions can never have 0 in the denominator. It can never be divided by 0 because it makes it undefined. So go back to all of our fractions in the problem and look at all of our denominators. Our denominators are x plus 1, x plus 2, x plus 1, x plus 2. We figured out the combination of all of those through our LCD. So basically what we are testing to see is if I have an x value of whatever, in this case -1, if I substitute that x value into any of these denominators and it makes it 0, that means I'm dividing by 0, which is undefined, which means that cannot be an answer. Okay, so let's check this. Here's how I check it. I go back to my LCD. My LCD is x plus 1 times x plus 2. I am checking by substituting in -1. So -1 plus 1 and -1 plus 2. Does that equal 0? That's the question. Well, right here, and if either one of these equals 0, it's 0, because 0 times anything is 0. -1 plus 1 is 0. And so at this point, it doesn't even matter what the other one is, because this does equal 0. And that is bad. Again, it cannot equal 0, because that means we're dividing by 0. So that means -1 is not an answer. So let's check 4, okay? So we've got, again, going back to our LCD here. This is our LCD that we're using. X plus 1, x plus 2, and we're substituting in 4. So our check would be 4 plus 1, 4 plus 2. Does that equal 0? No, because that's not going to equal 0, and that doesn't equal 0. So this does not equal 0. That's good. That is good. That means x equals 4 is a solution, and so you have 4 as the answer. Okay, so I know it's aggravating to get through all of that and then be like, oh, I got to do more. That is true. Now, I wrote all the little processes out, but honestly, y'all, you could just come back to the problem itself and look right here and go, okay, looking at this first denominator, does -1 plus 1 give me 0? Oh, it does. That means -1 doesn't work. Okay, let's look at 4. 4 plus 1, that's not 0. 4 plus 2, that's not 0. And I would end up with kind of the same thing here as well. So as long as it's not 0, you're good. Okay, so that's one example. Let's look at another example of a same type of problem. Before I move on, let me just do a quick note here. Notice, as you probably did, that the factors that we got when we factored this ended up being the same as the other two denominators. This does happen kind of often, okay, especially in like these types of problems and in this class. I cannot guarantee that this happens in future classes or in life, but you might just want to check that out, and that might keep you, save a little bit of time at least. So let's check out the next problem and you'll kind of see what I'm talking about. Okay, this one. We are looking at just the denominators first. So our denominators are x minus 3, x plus 5, and x squared plus 2x minus 15. Okay, so do a quick little check. If I had x minus 3 and x plus 5, would that be the factors of this? You can certainly sit there and factor x squared plus 2x minus 5 out, but it does indeed give you x minus 3 times x plus 5. And you always kind of want to double check that. Again, -3 times 5 is -15, and then -3 plus 5 is 2. So that's a quick way to check it. That actually helps us save a little bit of time, and that allows us to go straight to our LCD. So our LCD, again, you need one of each thing. So we need the x minus 3. We need the x plus 5. But we already have an x minus 3, so I'm not writing it again. And we already have an x plus 5, so I'm not writing it again. So our LCD is x minus 3 times x plus 5. Back to the problem. We need to write this as the factored form, x minus 3 times x plus 5. That will help us with our next step. And then our next step is to write each term with the LCD. So bringing down our first term, we have x over x minus 3. What do I need to multiply by in the denominator to get x minus 3x plus 5. Well, it already has x minus 3. We need to put x plus 5 beside it. And whatever you put down at the bottom, you got to put at the top. Plus 2 over x plus 5. What is it missing? It is missing the x minus 3. So we'll put that on bottom and top. And then we have 5x plus 9 over x minus 3, x plus 5. That already has both parts. So I'm not going to write anything multiplied there. Now that we have all of our denominators the same, order doesn't matter, we're multiplying everything by that LCD, that common denominator. And again, that was x minus 3, x plus 5. And that essentially multiplies and cancels this and every one of our denominators. So this will give us x times x plus 5 plus 2 times x minus 3 equals 5x plus 9. And now we can simplify. So, or distribute. This would be x squared plus 5x plus 2x minus 6 equals 5x plus 9. Okay, now that you've distributed, and that's where you're going to kind of figure out what you do next. After you distribute, look and see what type of problem it is. We have x squared, so that's a quadratic. That means I need to set this equal to 0 and solve, but obviously got a little work to do before then. So let's do that. So let's add like terms. That's going to be these two. That would be x squared plus 7x minus 6 equals 5x plus 9. And we need this set equal to 0, so we're going to move this 5x and the 9 to the left by changing both of those signs. So minus 5x and minus 9. That's going to be x squared plus 2x minus 15 equals 0. Those cancel. And now we're factoring again. So clearly, you need to remember how to factor, okay? All right, so x squared, 2 blanks, minus 15 equals 0. And a is 1, so a times negative 15 is negative 15. And b is 2. So what are our factors that multiply by, or multiply to negative 15 and add to 2? It's going to be 3 and 5. What are our signs going to be? So our signs are different, and the bigger is positive. So this would be positive, and that's going to make that negative. And then going back to our parentheses, or our blanks here, sorry, would be negative 3x plus 5x. Okay, so we're going to group. And in the first group, we have x coming out. That would be x minus 3 plus 5 coming out. And that's going to be also x minus 3 equals 0. So we have x plus 5 times x minus 3 equals 0. Let's bring it up here and solve those. So setting those equal to 0, x plus 5 equals 0, x minus 3 equals 0. Change the sign, you get negative 5. Change the sign by adding, and you get positive 3. And so again, is this our answer? No. Maybe. You don't know. Okay. And so you could get 2 answers, and both of them are the answers. But the only way you know that is to check. And again, how are you checking? You are checking that denominator does not equal 0 when you substitute. My pen is just hating me today. Substitute in x. Okay, so whatever you got for x. So again, you can go straight to the problem, or you can use the LCD. I'm going to show both and talk through both because I feel like some people need the process. And so our LCD is x minus 3 and x plus 5. We are checking negative 5 in that. So negative 5 minus 3 and negative 5 plus 5. Does that equal 0? Does that equal 0? Yeah, it does right here. That equals 0. So that's bad. That's bad. That means -5 can't be an answer. All right, let's take the same thing and do it with the 3. So our check would be 3 minus 3 and 3 plus 5. I only need one to be 0 for the whole thing to be 0, and that does equal 0. That's bad also. Okay, that means that 3 is not an answer. And this, I think, is where students start to hate me. Because if neither one of them work, then your answer is no solution or D&E in the computer. Does not exist. So our answer does not exist because even our two potential solutions, when we substitute them into the function, it gives us a denominator of 0. So one more time, if I take -5 and I plug it into this denominator, -5 minus 3 does not give me 0, but here it does, -5 plus 5. And then you can do the same thing with 3. 3 minus 3 gives me 0, okay? And so answer here is D&E. But again, more than anything, I don't want you to just write D&E. That gives me nothing. What I want to see is the work. And so the work, the process, understanding what's happening is really what I'm caring about here, okay?